Question 4, what is the correct formula for ammonium sulfate? So this one is coming back to your ions again. So we need to make sure you've learned all your the charges and formulae of your different ions, and then use them to combine together to make the correct chemical formulae. An ammonium ion is NH4+, and a sulfate ion is SO4 2-. So I need to get the correct formula by combining the ions together and balancing the charges. I've got 1+ here and 2-. The whole overall compound has to have no charge overall, so the number of pluses and minuses has got to equal 0. So if I've got 1+ and 2-, I need a second plus. 2+ plus 2- is 0. So I need to have a second one of these, NH4+. So my chemical formula is going to be NH4 which is C. Question 5, which numbers are needed to balance the following equation? So we've got a combustion equation here. So we've got octane combusting with oxygen, giving us CO2, CO, and water. We've got 11 oxygens on this side, and oxygen you can see is present in all 3 of the compounds. So it would be a bit foolish to try and start splitting up the oxygen amongst these 3 things without knowing anything else about what's going on. To start this equation, then to start balancing this, you need to look at the hydrogens, because hydrogen is only present in the water. There are 18 hydrogens here, all right, which must mean at H2, I'll probably have 9 waters. 9 times 2 is 18 hydrogens, and I've now got 9 fewer oxygens to share out from the original 22 that are here. Remember, 11 times 2 means there's 22 oxygens to split up, okay? So I've got 9 waters. What that does now is reduce your options. So with 9 waters, it can only be A or C. So here you've now got a process of elimination. You can try both of them and see which one fits. Okay, so we try the 5, 3, 9 first of all. Well, let's have a look at what that happened. What does to that one? That will give us, right underneath, 5, 3, and the 9 we've already got. We've got 8 carbons, that works. We've got the 9 hydrogens, which we've already confirmed. And we've got now 5 times 2 is 10, plus 3 is 13, plus 9 is 22. So there we go. We've confirmed it. It is definitely A, because that one works. 5, 3, and 9. If you want to double check it for sure, look at this one now. 8 carbons in there, all right, and there's 1 there, which gives you straight away 9 carbons. There's only 8 to play with, so that's going to have to be wrong. So there we go. So the answer to question 5 is A. And the final question, question 6, which is the correct pair of molecular and empirical formulae? So remember, the empirical formula is the simplest whole number ratio. The simplest whole number ratio. This question is commonly answered incorrectly because they haven't simplified it down to its simplest whole number ratio. So let's go through each of these one at a time. C4H12, all right, that can be simplified to C2H6, but that can go down again to CH3. So the simplest whole number ratio there is CH3, so it can't be A. B, C8H18, that's an alkene. C4H8, so what have we done there? We've taken that down by 4, but then that down to 8, so we've halved it again. Well, that doesn't work, does it? Because half of 18 is not 8, it's 9. So that's just wrong altogether. Question C. Answer C, C6H12 to C3H6, we've halved each one, but again, this one could go down once more, just like that one can, to CH3, or CH2 even, I beg your pardon. Okay, so that one can go down again. All right, if you were to divide this by 6, it gives you C, and that by 6 gives you 2, so CH2. And then D, so by this process of elimination, D has got to be correct, unless we've made a mistake somewhere, but let's just be sure. C4H8 down to CH2, well, you definitely can't simplify that down any further. Is this a simplification of this one? Well, yes, because you divide C by 4, it's just 1C. Divide 8 by 4, it's 2. So that's correct. Therefore, question 6, the simplest empirical formula there, the correct pair is D.